We are building the Wordle project from the WiByte Python curriculum available at www.wibyte.in. In the last few videos, we have spoken in detail about what happens when I have a repeated letter in my guessed word, and so much so that the number of repetitions is more than the repetitions in the original word, in the chosen word. For example, here, let's say the chosen word is pages. If I try, let's say sissy, just an extreme repetition, notice all three S become yellow, and that's strange because that is giving a wrong impression to the that there are three S's in this word. We have in fact spoken in detail about this problem. We have analyzed this quite carefully and come up with a solution. In this video, we are going to implement that solution because that is when we'll really understand how this is actually working. But before getting there, let us first revise the solution. Remember, the idea was that we are going to figure out the difference between the number of occurrences of the given letter in the guessed word and the chosen word. We'll call this M. We'll follow this notation in the code as well. And we will change the first M occurrences wherever we see yellow to gray. Now, like I said, we have spoken about this in detail with several examples. I assume that you've looked at that and kind of convinced yourself that that is going to be correct. Let's get on to this implementation now because that brings the next level of understanding. So, like I said, I come here to my code. The first thing to remember is that the problem is only to be seen in case of golden letters. If it's green or gray, then there's never an issue. So accordingly, I come in here to the section where I have an incorrect letter. I am going to find out the difference between the number of times this letter occurs in the guessed word versus say the chosen word. I'm going to call this M. How do I find out how many times this letter occurs in the guessed word? Well, I can use the count method. So I can say guessed word dot count, for example, guessed word KK, because that's the letter we are interested in. Remember, this is running in a loop. KK is the count of the letters. So I'm just finding out guessed word KK, that letter, how many times does it occur in the guessed word? From here, I'm going to subtract the count of guessed word KK in the chosen word. So this may look a little bit confusing, but this is really not. All we are trying to find out is how many times the letter occurs in the guessed word minus how many times the letter occurs in the chosen word. That's why it's guessed word dot count, chosen word dot. Now, having done this, I need to, like I said, make the first M labels from yellow, change them to gray. Now, that is, I'm going to say, okay, let me use a counter here. So I'm going to create a variable, a local variable here called CNT. Now notice this CNT is a local defined inside the function getWord, which means that whenever I click the guess, CNT will become 0 again. So it's always being done fresh for every new word. What I'm going to do, and I'll first write the code here, then we'll look at how it's working, why it's working, and so on and so forth. It's actually very interesting. I'm just going to put a small bit of code here. I'm going to say, look, if CNT is less than M, then, well, I'm going to change this label into, um, I'm going to change this label into the gray. And of course, I'm going to change CNT is equal to CNT plus 1. So repeat it. Really, this variable CNT is keeping track of how many times a letter has been repeated on the yellow position. For the first M of those, it is setting it to, it is changing those to gray. This code is really, really interesting because think about it, for all the analysis that we did, it's finally just down to these few lines of very simple code. But let's first convince ourselves that this works. Once we do that, we are going to come back and look into this in a little bit more detail. I'll try to explain to you why this code is actually working. That it's also quite interesting. Let's say the word chosen is shelf. Now, once again, there's only one S on this. So I try, for example, let's say, let's say stops. Now notice stops has two S's. One is in the right place. That is green, but the other one now has dutifully become gray, which is what is the right thing. Let's try one more word. Let's say, pulse. Now pulse has got two L's, and I'm intentionally trying it this way. This has only one L. I click on guess. Notice the first one has been made gray. If I did not do this piece of code, the first one would have been yellow because it's in the word but not in the right position. But now it's gray. Of course, the second L should be green, and that's correct. This S is in the word but not in the right place, and hence it's also correct. Notice how the repeated letters are being taken care. Let's say I tried sissy. Again, notice only the first one is green, the remaining two are gray, and this is the right indication, right usage for my player, because now I know that okay, there's only one S, it's in the right position, the other two can be ignored, or there are no other S's on this. So we see that this is working, but really, why is it working? How is it working? Let's get a little bit deeper into this. Now, one way to do this analysis would be to put a bunch of print statements here. So, when I come in here, I put count, but I found that that's a little bit hard to understand. So what I will do is that I'll just take you back to your class notes, and I'll run you through several cases on what's going on with the variable count and the M. And we'll try to sort of make sense from there. In in fact, that lead us to a very, very interesting discussion where we'll find that even this code still has a bug. We will come back later and fix that, but it's important we understand how this is working because that leads to a logical development further. Now let's start with some examples. Let's say, the chosen word is adapt and my guessed word is abaca. Now remember in this case, first A and the second A, so A is the repeated letter, second A that I have in the word are all greens, so the problem doesn't even come there. I come to the count here. This is where my CNT is 0 and my M is 1. And why is M 1? Because there were 2 A's on the chosen word and 3 A's over here. So the M was equal to 1. Count was 0. I just had a condition. If count is less than M, change to gray. And that's what my code is doing. I go and change this to gray. Let's look at another example with the similar numbers. Level chosen word, Erie, the guessed word. Erie has got 3 E's, level has got 2 E's, hence again M is equal to 1. The first E that I encounter happens to be a yellow, so check, well, count is 0 in this case because that's where I start. M is 1 and hence I am going to make this into gray. Next one is fine because it's in the green position. When it comes to this particular E, it is a yellow, which means count is 1. Remember, count has been incremented when I encountered this. Count has become 1, but notice M is also equal to 1. So, which means I will leave this untouched. I will not go and change this because remember, the fundamental motto was that I am going to change the first M yellow occurrences to gray. And the first M basically in this case means the first yellow occurrence. In this case, first happened to be this. In this case, first happened to be, let's say, this. So I just make this gray and the code works. So these two will make gray. Let's take a few more examples so that it becomes clear. Let's say the chosen words is dates and I enter CC. Again, this is M equals to 2 because 1 S in the, chosen word, 3 S's in the guessed word. Now here what happens is, first time I encounter S, count is 0, M is 2, M is always 2 anyway. Next I encounter S, count has become 1, M is 2. Next I encounter S, count has become 2, M is 2. I will change those to gray where count is less than M, which means I'll change this and this to gray. I actually had that here, but it's getting cut off in the screen, but never mind, you get the idea. I'll change this and this to gray. There'll be one S left and that will be yellow. That's because count here is equal to 2. Once again, count is helping me count the first, count is helping me count the occurrences of this yellow, let's say, repeated letter. The first M of those I'm converting, and that's basically count less than M because count starts from 0. Again, similar example, dates and abaca. Now these have been chosen obviously to make a point. So here I say, okay, look, there's only one A over here, but here count was 0, count was 1, count was 2. In both of these, count is less than M. M is always 2 anyway, and hence I will convert both of these to gray. And that's how the code is really working. Let's take one more example because that will lead us to the problem that I was saying earlier. Now, look at this. Again, the word is dates. I choose fussy. Count is 0, count is 1. Count is less than 1 for this case. So I go and change this to gray. I end up with just one S, which is yellow, which is perfectly fine because again, M was 1 over here, right? There were two, say the guessed word, 1 in the chosen word. We're talking of S here. M was 1 and hence I just basically converted the first one to gray. Look at this. This is a really nice example. In this case, I've got two S's. The first encounter happens with this S. Count is 0 because that's where I start. M is 1 because we discussed there are two S's in this, but there's only one S in the chosen word. So count was, M was 1. Count is less than M and hence I convert this to gray, which is perfectly fine. Now you may wonder what happens to the T over here, and this is really what I want you to think about. T is in fact also a yellow letter. Now, when I get into T, remember S has made count equal to 1. And most importantly, for T, the M value is actually 0. So that's why I said M is 0. That's because there's one T in dates, one T in fasts. So T is actually 0, count is 1, M is 0. T will not get influenced. T will actually remain yellow, and that's what it should be. Because remember, for every letter, we are doing this count of M again and again, right? So I hope this is kind of giving you a picture of how this is working. Let's, however, go back to our code once again. Remember, I just come in here, I find out the difference between the occurrences in the guessed word and the chosen word. If count is less than M, I go and convert that to gray. Really, really interesting, thought provoking. So think through this very carefully. However, there is a very, very interesting problem that still doesn't get solved in this. What happens if I try a word where there are two repeated letters, for both of which there's only one inside this? Now, I've chosen this word called seeks. Remember, there are two S's in this, but there's only one S in the chosen word. There are two E's here. There's only one E in the chosen word. Now we notice that when I try this, this goes wrong because now my second S has become yellow when I expected this to become, in fact, gray. For E, it looks okay, but really what happened was that, remember, we are doing this letter by letter. So first time I come into this yellow was in fact with this E, because that's where yellow was. It found out that, well, look, there are two E's in there, count is less than M, and I converted this E to the gray color. Unfortunately, however, when it came to this S, this is very, very interesting. When it came to this S, count was already 1. So I found out, yes, there were two S's in the guessed word, one in the chosen word. The M should have been 1, but my count had become 1 already because of the E in there. Because this E had fixed it to 1, and hence this condition never happened. My code unfortunately did not respond to this. Now we can fix this by keeping track of the repeated letters, by making a list of letters and so on and so forth. But we will take that in a separate video because that's really a little bit more involved in this. But I hope you kind of got the idea of how this is working. The thought process here is important. Notice how we first analyzed the problem. We came up with a solution, we implemented that, tested that, and then we realized that, okay, look, there's a little bit more to be done still. That logical thought progression is what is the most important thing about programming. And I would want you to inculcate that. Hope you found this interesting. In general, if you think this way of learning by building challenging projects, applying ideas, thinking through them is your cup of tea, look at our website because we have many, many, many such activities. Take care. Thank you so much. Bye bye.